Hey, so I hope this works because I have just this second finished installing the new version of Rider because it expired just as I launched it a few minutes ago. So with luck everything still builds and nothing exits out randomly. Tests seem a lot faster than the last build, that's nice. I did actually run them, didn't it? Yeah, that's definitely quicker. Cool. So, today's plan is not that, and not that. Oh, I'll just go to it here. There we are. I added a to-do list to the top of the Markdown document so that I could keep a track of what I've forgotten to do. I was going to do the HTTP API today, but then I decided that it would probably make more sense to do storage first, because storage is what's going to also, as well as committing the events to disk or wherever, is also going to run the projections when you actually save. And the REST API wouldn't be much use without projections, because we're going to be wanting to write some projections to return custom views for various things like toggle statistics or all of the toggles available in the system. So with that, let's go on to the storage API. Now, I don't actually know how... Oh, let's go to presentation mode. Right, I don't actually know how I want to structure this API yet. So I figured I'd just hack it around in there in the scratchpad. I have a vague idea. I'm thinking something along the lines of where it could be decorated onto a session or a request. And in which case I'm going to want something along the lines of auto-committing. So when a request comes in, start a connection, allow subsequent handlers to load items and load projections, and add in aggregates that they want to save. And then at the end of the request, everything gets committed. So from that perspective, I'm going to want some kind of interface like storage system something. That'll do for now. I suppose we better have a void. No, let's try a void instead. Probably slightly more valid. Open or begin session. Actually, let's make that return an I storage session. Yeah, and then we'll have an interface which is the I storage session, and let's have a void open. And at the end of the session we're going to have a void commit. Do we want anything else really? I think it should implement iDisposable, and we'll have the dispose method check if there's anything to commit and commit. And I guess we want a void close as well. Probably a method to load things, so t load aggregate. Let's call it t aggregate instead. Which will take in an ID, and all of my IDs are GUIDs, so we can just make it a GUID parameter, aggregate ID. And a T projection. Oh, let's actually Oh, can we add things? Yes, we can. Where T aggregate is aggregate root. Yeah. Let's leave it at that for now. And actually, let's comment that out for a second. So this is going to be a read-only session. So, I guess an implementation of it. Actually, we can ignore the storage system for now. That storage system will probably end up being what creates an equivalent of a document session in Martin or RavenDB, or a document. What's the term? I think it is documents system or document store. And then you create a session when you want to do stuff, and the store is what you configure the sessions with. So let's have a public class in memory session. That's going to take in. No, let's not take in anything yet. But we'll implement the interface. storage session. Right. Let's move the dispose down to the bottom where it should be. And dispose is going to say something along the lines of, if anything pending, whatever that might be, commit, and then close. And we don't have that yet, but we'll leave it there just in case. And for an in-memory one, don't actually need to do anything, I don't think. And loading of an aggregate. Well, as this is an in-memory system, we can just have a aggregates collection, which can be a dictionary of GUID aggregate root. Oh, a new dictionary, that would make more sense. We'll make that read-only. And this is going to say something along the lines of no, that's not right. It's close, but it's not right. We shouldn't be storing the aggregate, we should be storing a list of events. Otherwise it's not much of an event store if we're not actually storing the events. I mean, technically the in-memory one doesn't need to store the events, but we might as well do it like that, because then when we come to implement say file system or database back to storage, it should only be how the events are loaded and persisted that will change, and the actual replaying of them and how we set that up should be the same. Now, what we want to do is say list of events to load. If try get value aggregate ID out events to load, if it equals false, throw new not found. Do we have anything generic? Entry point, key not found exception. Yeah, it'll do for now. Unable to find an aggregate with ID. Nope. We can interpolated string. aggregate ID. That'll do for now. Otherwise, need to construct the aggregate somehow. So we've got some events, and effectively we want to do something along the lines of toggle.load from something followed by our list of events. God, my typing is really going to hell today. Now, we obviously don't want to hardcode this. So what I think we need to do is provide another dictionary of type func aggregate root. Is that right? No, that's not right. It's going to return an aggregate root for sure, but it actually wants to take in a list of events, and it's going to return builders. Let's try that. So here we now say func list event. I need more generics on this line. Aggregate root builder. If builders.try get value type of t aggregate out builder, and we'll say if that equals false, throw new not supported exception. Why not? No builder for type type of t aggregate dot name found. Verbatim. Right, so if we get this far, we now have some events and we have a builder. So we can now say var aggregate equals builder, invoked with the events to load, and then we return a casting of that aggregate. Well, it might work. Oh, we have absolutely no way of testing it because there's no way of adding the events into the dictionary. And as I don't want to implement that yet, what I'm just going to do instead is move this up here. So if we... Can I make Sharper do this for me? Move assignment to initializer. No, that's not what I wanted. I think if we just do that. Yes, there we go. Right. So open doesn't do anything, close doesn't do anything. We have a method to load and we can pass it in a dictionary that's full of stuff already and check that things can actually load. Oh, let's see if it works. Var builders equals new dictionary of... No, actually, let's not do it like that. We'll do var session equals new InMemory session. And that is going to take builders and I don't want to call it that. That's a bad name. It used to be aggregates before I changed my mind. Events. Yes, rename everything. Good. So we'll take in some builders and some events. Do that. Create local variable. Yeah, that'll do. Right. So let's take that. Replace it with var equals new. Do that. Delete that. Right. So here we can do type of toggle. So that's the only aggregate I've got. And hang on a minute. I'm getting confused. Right, this is the builder, yes, events. So when given some events, we will return toggle load from. Let's return a blank string for that and pass in the events there. Still not sure where this is coming from yet, but that'll do. What is your problem? Oh, yeah, I suppose. Event store. Why is... yeah, well, I haven't written it yet, that's why. Var event store equals new dictionary. Right, this is the one that's going to get some events. So let's have a GUID, which can be our random GUID, GUID.newGUID. So this is going to act as our dummy aggregate. And so we say ID, and then we need a, what the hell's an editable list? Aren't all lists editable? New list of events. And let's do this. var events was new event. Do an event array for now. Well, might as well make it a list to start with. List event. Alright, I want to call these E. It's a lambda, so we can get away without naming our parameters properly. New toggle created, and that takes an ID, which we've already specified, and name, first, and a description, hi, and then we will say new toggle, no, tag added, 1, new tag added 2, new toggle switched on. Right. Ah, and my parents decide now is the ideal time to Skype me. Maybe later. Right, events. It's a trouble. I remember to sign out of everything on my laptop, and then I forget that Skype is still signed in on my phone. Right, so we've got our fake event store. So var toggle equals session.load aggregate toggle ID. And before we run it, let's write an assertion. Toggle that should satisfy all conditions. Now, after it loads, copy toggle.id should be ID. Toggle.date active should be true. I'm not going to test all of them because we've already got tests that prove that toggling works. Just want to check that some things are there. Toggle dot tags should contain 1. Right. Let's see if our first really stupid event store works. That runs. I'm just going to check that this is actually on, because I tried streaming again the other day, and although it appeared to be working, complete and utter nothingness was coming through. So I'm not sure if it's actually my broadband or OBS or what. Oh, excellent, it is actually on. And hearing my own voice coming back through that is really weird, so I'm going to shut that again. Right. Well, that worked. It seems to have done. Let's do that. No, let's in fact do that. Remove it from the store completely. Key not found. Unable to. No, that doesn't actually say what it. Unable to find an aggregate with the ID, blah. Yep, good, that works. Right, so we have a vague event store. So let's actually put it somewhere. We'll take that one, move to iSession, and we'll take that one and move to that. Then we will take these both and put them in. It is technically infrastructure, but I think we'll have a folder for it. Storage. Move those there, fix their namespaces. Not open the files, apparently. Okay, there we go. Right. Let's add that in, because that's what I'm going to do next. And I will just make that implement, and then we'll commit these. Let's make sure there's no bad white space, because that's a bad thing. No, don't do that. Thank you. Oh, I hit Control W, and apparently it's still slow as hell to deal with that. Right, let's commit these. Let's clear that. I don't want to commit the scratchpad. Git reset head source Crispin tests. See, there we are. Let's see. Storage. Read-only in memory store. Rich. Right. So now that we've got some in-memory read-only storage, let's leave that for now. Let's add saving. So our storage session. So we can load an aggregate, and what we want to do is have void save I evented aggregate. I think this actually needs to be a generic. I'm reasonably certain that we need a property that's only available on aggregate. It is not part of this IEventity interface. So we do this. We say aggregate where T aggregate is an aggregate root and is I evented. Although aggregate root implements I invented. So I don't need to actually do that. Nice. So we'll just leave it as that. And in fact, as we're not caring about generics, we can do that. And now we can get rid of that. Less pretty, but simpler is better. And simpler it is, the easier it is to understand. And the easier things are to understand, the better. Our job is too difficult already, so... or is difficult enough already. I'd rather not make it harder. Right, so now we want to save an aggregate, which in our case is going to be fairly straightforward. We're just going to say is there an events.tryAdd? No. Might end up having to use a concurrent dictionary later. Oh well, we'll worry about that later. Yeah, I'm going to ignore threading entirely for the time being. So events contains key aggregate.id false, then events.add aggregate.id new list event, and then we can say events aggregate.id dot add range aggregate dot that would make things easier, wouldn't it? So that I don't have to cast it to both things. Let's go back and make the interface use that generic version. T aggregate T aggregate where T aggregate is an aggregate and implements I evented. And the reason for doing this means that the parameter, just take that bit and replace that bit. So because of that generic constraint that we have, we now should be able to see all of the methods on it. There we are. We can get at these without actually having to do some casting. The gel mega, I hope I'm saying that right. I am making a feature toggling service for fun and profit, maybe less profit. If you go onto my GitHub, it is available on there, and you can just see the README document about all of the things that I'm trying to implement as I go through. It's mostly as proof of concept, but I also might end up looking to use it at work because for various reasons we don't want to use cloud hosted services. We want something internal. So I figured it would be a fun project to do, and I'm going to try and stream the entire development of doing this as much as I can, which has only been thwarted by Twitch not streaming once so far, and I've only done like 6 streams, so 1 in 6. Right, so we want to get the pending events and add them on here. Why can't I just do that? Argument undeniable of object is not a... yeah, I suppose. They are. That might be something we need to come back and fix, actually. For now, we'll just cast them. And as we don't have any kind of actual save logic, we can just do aggregate. No. Clear pending events. yeah, this will work, but there are a couple of issues with it. The first off being that you could overwrite things. You might end up with an invalid stream if you save two instances of the same aggregate with different event streams. One of them will get appended on top of the other one, which will cause weirdness. But for our initial MVP, so what I'm going to do is keep the ID. No, I can't keep the ID. I'm going to scrub those and go var input toggle equals toggle.createNew. I still don't know what I'm going to put in there yet. And then we want a name first, and a description of hi. So I'm just going to recreate the same thing, but actually using the domain methods that we've got. So a feature toggling service is just a way for managing, or centrally managing, all of the feature toggles that you want to use for an application. Feature toggles themselves are so that you can switch on and off features for testing purposes usually, or phased rollout. Say you had an emailing system built into your application and you wanted to replace it with a new emailing system. You wouldn't necessarily want to release it to everyone at once, because if it breaks, you're going to affect everyone. So what you do is you put it behind a feature toggle, and you have the toggle switched off for everyone except for maybe one user. And you roll it out to them, and if they're happy with it, you then roll it out to a few users, and then more and more and more. A lot of large websites like Facebook and such use feature toggling extensively. There's a way you can deploy things with demographics. So you could say, only deploy this to people with kids of a certain age who live in this country. That kind of thing. There was an anecdote about Facebook always released to a certain group. It was something like mothers in the age of 30 who live in the northern island of New Zealand got features first because it was a small target group. I can't actually verify how accurate that is, but yeah. Feature toggling also enables you to commit things to master and get them into production quicker, but hidden behind feature toggles so they're not actively used straight away. And I like feature toggles, and one of the difficulties with them is stale toggles, so ones that you've created and then have either fallen out of use because the project has finished and the functionality's been switched on for everyone in the world, and you kind of forget to remove the old toggle, and so you end up with a lot of clutter in your code. So one of the goals of this service is to give some kind of alerting when a toggle hasn't changed state for a long time, or hasn't been queried, that kind of thing. I call it aggressive toggle management, so that you don't hit problems. So yeah, like I said, seems like a fun project, and it gives me an excuse to mess about on .NET Core, and yeah, if I break things, I'm not breaking anything important yet. Really should put the whole service itself behind a toggle. So, yes, we want to add a toggle. Oh, I'm also doing event sourcing in this because I think everything should be event sourced, and I try and do domain-y type objects, so rich domain models. So everything you can see is public, is privately set, and you can only get at changing things via methods that are actually named what you want to do. So in our case, I want to add a tag called 1, input toggle.add a tag equal to 2, and input toggle will switch it on. Now I don't need that, but I'll just comment it out for now in case I want to go back to the old version. Here we'll do input toggle.id and there, and before we can load a toggle we should probably save it. So session save input toggle. Right, with luck, saving that will dump all of the events that we've caused to happen here into our backing dictionary, which then, when we call load aggregate, will successfully load them and should return us an object that matches. Fingers crossed. No, that was the previous one that was broken. Good. Better. Ah, even better. So we have vaguely working feature loading of feature toggles as well. That's quite cool. So I think what we should actually do before committing things is move the tests into an actual test file somewhere. So we will match the namespace, infrastructure, no, not a class, directory called storage, and we have some, now I think just the one test file to start with. I was considering doing like in the toggle tests where we've got one for each area of functionality, but I think the storage is actually going to be fine-grained enough that we can get away with just one. So in memory session tests, let's grab that and that and that. We still can't import things apparently. What about now? Nope, nothing is happening that's useful. But we can import specifically. Useful. Right. Let's get rid of that and just have that. No, not that. That. New in-memory session. Yes. Import. There we go. And because that's going to annoy the hell out of me, these should be in alphabetical order by default. Right, and we shall make that a field. Field. Yep. And I think we'll make that a field as well. And that because we might want to assert on the content of it. So our tests will be when there is no builder for an aggregate, when there is no aggregate stored, and I think an interesting one to do would also be when there are no events for an aggregate. This one, I imagine, will fail because I've written it badly. Right, so now we've got some negative cases. Let's have a happy case. So when an aggregate is loaded. Note we're only testing for loading at the moment. This is not a run through, so in fact, when saving an aggregate, right, that one's easy enough. We do underscore builders clear, and then we just try and do session load aggregate test. I don't want to keep re-implementing an aggregate each time. I might have to create a test data namespace and put some test data in it. You know what, let's actually use the toggle. Might as well check it works as well. Load aggregate toggle ID aggregate ID, and I'm going to make that create a field called aggregate, and we shall give it an ID. As we're testing with XUnit, the constructor is acting as our setup function and runs before each one of these tests run. So you get a separate instance of the class for each fact method. If we implemented iDisposable in the class, that would act as our teardown. This means that I can do all of my setup here, such as generating new GUIDs and such, and they'll be unique for each test run, or each test in the class. No horrible shared state like other test runners, cough cough NUnit. Right, with this, now, knowing how this is implemented, it actually checks that the builder exists after it loads some events. So I'm going to cheat and I'm going to move that first, because there's no point going to the event store if you can't build the actual aggregate, even if you find the events for it. This will be the same when we do S3 or Postgres or other kind of storage backends, because we'll be able to check if the builder exists, and if it doesn't, we'll throw before we even try and load, which should save us some round trip time. And in the case of, say, S3, it'll save you a little bit of cost as well. So we're expecting this to should throw. We should probably put a decent exception in at this at some point. Not supported, rather than just a generic not supported error message. Right, when there is no aggregate stored, so we don't need to do anything here. Just take that exception, do that. What kind of exception should this throw? The builder is there this time, so we'll get a key not found exception, hopefully. When there are no aggregates for an aggregate stored. Right, so this is where we want to say EventStore equal underscore aggregate ID equals new list of event. So this should never happen in a production system, because storing an aggregate, it won't ever commit it until there are some events to store. But we can cause this to happen with our InMemory version, so better test against it as well. And finally, we want to load one, so I'm just going to go here, steal these, uncomment that, hit the right shortcut key and uncomment it. No, we still can't import things, that's useful. That wants to be an aggregate ID instead. We can actually get rid of that bit and just say EventStore underscore aggregate ID equals that. Blah 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 blah. Take that. Make that access that. Use the aggregate ID here. And just prove vaguely that our toggle worked. That should be the aggregate ID. So we're just checking that it's got an ID and it's applied one of each of the types of events. Let's get rid of that for now. It doesn't really add any benefit. And finally we want to implement save, so that is grabbing this. Create new, blah blah blah. Let's rename it toggle. Then we say session save toggle. Okay, thanks for watching, and hopefully see you again soon. And then now we can just check that this has the right thing in it, so we can't use that, we have to use that ID instead. Right. I don't want to check that all of the events have exactly the right thing in, because we have tests that cover that already. So select e.getType. Should be new array of type of toggle created, type of toggle, no, tag added, type of toggle switched on, and I'm going to remove that as well. Right, if we're lucky, this will all pass. If the solution compiles, which it doesn't. It's weird how this presentation mode doesn't zoom in everything on screen. And does interesting things with the icons as well. If I remember, time to submit a bug report, I think. Right, now that we've extracted all of this out of here, oh, I don't have Git integration switched on apparently. Oh yeah, because it annoys the hell out of me. Source, let's make sure I delete the right thing. Crispin.tests, scratchpad. Boom, there we go. The question is, do I have bad whitespace in here, and has my reformatting worked? It looks fine. Let's add some. No, reformatting still doesn't work. Oh well, at least I seem to have a consistent reproduction of it. Did I actually run these tests, or did I imagine it? I don't think I actually did. Hopefully I meant to run all of them, not just one. Ooh. Ah yes, this is the one that I thought might break. Because we're just checking if the events existed. So what we can do here is just go and events to load dot no any, rerun the tests. Oh, not any equals false. I want a none extension method for that. Still, at least we've got tests. I didn't have to run the whole application to find out what. Or. Yes, if that is false, or that, yeah. Still, this is the benefit of writing tests. Ah, I'm asserting on the wrong type. It's not that that's not supported, it's that the key wasn't found. Yeah, that makes sense. Hurrah. So what's the difference here? Storage. Implement in memory saving of event. Right. So now that we actually have saving of events and loading of events, we've got two choices. We can either implement the commit and close and dispose logic and possibly open, or we can do the more interesting thing of projection running. I think actually projections are going to hang off that commit message or commit method. So it'll make sense to implement those first. So now that we have an in-memory session, this is where we need our in-memory, our iStore interface. So let's add a new interface. iStore, yeah, iStorage, that'll do. Which has an iSession open. Now begin session. Now this might not seem important, but if we now implement it, public class in memory storage, influence iStorage. So here we actually say var session equals new in memory session. Oh, not that. Would you stop it? Oh, okay, we'll just put null. No, we'll come back to that in a second. We open the session and we return the session. Now that we have some configuration areas, we can say we can put our configuration on this storage. So configuration that's going to cover all types of things is going to be the builders. So let's have a void register builder t aggregate func list events t aggregate list of event builder. I got enough? Oh, too many angle brackets. Oh, where t aggregate is an aggregate root. Right, so we can put that on there. Let's go to our in-memory session and steal that. Let's initialize it. Let's not do a concurrent dictionary, let's do a normal dictionary. And this register builder, all it's going to do is say builders.add. So this will throw if you try and do something stupid, like you're registering the same builder twice. The type of aggregate is builder. Yeah, good enough. So now we have an answer for what that is. And now we need to look at this. Now, what I'm thinking is, because you have a session, you open a session and you can read data. And then when you close the session, if there's any data that you want to save, that gets flushed to the database in the end of a transaction. So I think we're going to end up with some dictionary copying. Some dictionary copying type semantics, is that the right word? I'm not sure. We'll go with it. So let's use the same one of those as we had before, and we're going to pass it in here. Doesn't seem to do anything different, but it's the implementation of this that's going to change. So what we're going to do is we're going to rename this underscore store events. Yep. And then when you call open, we are going to create our own one, events. Actually, we don't need to do anything on open. Let's do that. Events equals. Let's steal that. We'll call this, rather than calling it events, we shall call it pending events. So, nothing. But when we save an object, so that's going to read off the store. I guess. There's an interesting use case coming up here. But when you write, what we're going to do is actually write it to the pending events. And there's several interesting points here. The first off is, do we clear pending events until we immediately after you call save, knowing that they're actually only in memory? It's only when you hit commit that they've written to disk or to storage. So we probably should actually call clear pending events here rather than here. Leave it there for the second. But when you call commit, what we're going to do is take our pending events, say for each in pending events, what's the nicest way of writing this? If store events contains key pair.key double equals false, store events add pair.key new list of event, and then say store events pair key dot add range pair dot events. Oh, bang. That'll do. So, if we were to rerun all our tests, our save test should now fail, because it'll have only written to the pending events. We'll actually need to call commit before for it to actually appear in the session. So let's have when saving inaccurate, and and commit is not called, and we want a very similar test, and commit is called, session save, session.commit. So our assertion here should be that store should not contain key toggle ID, because it should only be in our pending list. Right, let's run all of them. And my laptop is now trying to take off from the sound of the fan. Come on, an in-memory event store with 3 events really shouldn't be that taxing. Right, so now that we've got that working, we have an interesting dilemma which can be shown with this test. When loading an aggregate greg8 saved in the current session, we have 2 interesting errors here. If we do this, and then we do that, call that loaded, and that should be that. Now, that's going to fail because we're not calling commit. But I think you should be able to get the aggregate out of the current session. I mean, you just put it there. And I did have another test case for this as well. No, that'll actually work. Never mind. So this should fail because our load method at the moment is only looking at the store's events. Oh, and I have thought of another test case that will fail as well. So let's take the whole test and say bye white space. When loading an aggregate existing in store and saved in the current session. So in other words, we do that. Let's cut that instead. Then we say session.commit, and then we do toggle switch on, session.save toggle. We want that to work as well. And at the moment, I have no idea what it'll do. Failed miserably, I'd imagine. Actually, this one will work, but the toggle will be off because the off event is persisted in the pending event list, whereas everything else, because of this commit call, is in the store's event list. Well, let's fix this one first, which might make everything work, if we're lucky. So, we don't want to touch saving, it's only loading. I think what we can do... will that work? Yes. Let's say have to be careful because we don't want to break that. That's the way to do it. Right. So we'll start off with our var events to load equals a new list of event. We will now say if store events contains, we'll cheat. If that contains that, then events to load, add range, store events, aggregate ID. If pending events contains key, aggregate ID. Events to load, add range, pending events, aggregate ID. So the idea is that if you have something in the store, we will put all of the events into a list. Then any subsequent changes, which are things that have happened either in the store since you started the session and have committed your own stuff, we'll append those on the end. And to keep this exception around, we should now, rather than doing that, we can just say if events to load any equals false, because now it doesn't care whether it came from the pending events or the store events. We'll still throw an exception. Then load, yeah, maybe. I'm hoping all except for maybe one of these pass. I mean, it'd be nice if they all passed, but that seems a bit much to hope for. No, is that we're at 2 failing. Yeah, that should have worked. No, it shouldn't. Would help if I loaded by the right thing. Ooh, nice. Excellent. Now, the reason we implemented all of that is because now you can open and close these sessions as much as you want, and you will have data. We haven't implemented committing yet, though. See, would that be difficult to do? Close. I don't know if that needs to do anything. If you close a session, you've got pending things to commit. Should that throw an exception? Or is it literally the same as calling dispose? I think it is the same as calling dispose. So I'm going to get rid of it. iSession. We don't need a close because we have dispose, and the reason we have dispose is because then we can use the using statement with stuff, which means we don't need that in there, and now we just need to do some kind of commit logic. It would be something along the lines of if pending events any is false, return. Otherwise, commit. Probably could do with a test for that as well. Yeah, I'll just do fact. When there are pending events and close dispose is called. For that we can just do that. Session save. Session.dispose. And now we can say we do have the event list, don't we? Yes. EventStore toggle.id .select e.getType. So we have the types of the events. Should be a new array of toggle created, type of toggle, no, tag added. Hurrah. Let's add everything that's been updated. Cat source has been infrastructure storage iStorage. Yep, we'll ignore that bit for now. InMemory store implement commit logic dispose logic. Cool, I think that'll do for this evening because it's dark and I'm tired. It being Finland, we're 3 hours ahead of UTC, so it's 11:15 and I'm not getting any younger, so I'm going to bed. Thank you very much for everyone for watching. I hope you enjoyed it. As always, if you've got any questions or want to have a poke around, my GitHub link is in the Twitch channel, and follow me and have a chat on Twitter if you want. So yeah, see you all probably tomorrow, if not Wednesday.